Okay, so today we're going to have a really quick update here on Planet Nibiru. Was reading an article on the UPI. There's a large-scale motion being detected near the San Andreas Fault System, um, which is obviously cause for concern. You can see here on this model that they've put together, the red areas are the areas that are actually rising. And then the fault itself, as you can see, there's the cracks running through, and then we're getting a lot of pressure building around the fault system itself. That's never good. I'll put the link to this article and down below the video. But basically, I have identified a 125-mile wide section that they're calling lobes of uplift and subsidence, which is not good. It just means that there's a lot of pressure building around the San Andreas fault. Obviously, there's always pressure building and releasing on that fault line. The pressure builds, and we have an earthquake, regardless of what the magnitude is. It does release the pressure. So let's hope that it releases in a smaller magnitude quakes. However, sometimes as you know, they do go into larger magnitude quakes. So we'll take a look at the one day. Today we've had 26 earthquakes, and it is the 21st of July in 2016. So out of those 26 earthquakes, I think the largest was like a 5.2. Yeah, 5.2 in New Caledonia. And some of the others, we did have a lot of fours. As you can see, there was 4.6 in Japan, which is pretty close to a 5. We had a 5 in Vanuatu, 4.8 in Micronesia. One other thing I wanted to take a quick look at was the solar system scope. I love the software, and I think it's just a great piece of software if you want to just kind of get an idea of how the solar system works. You can plug in dates and times and see where things were. When there's comets moving through, you can plot them on here. There's just a lot of cool things that you can do with Solar System Scope. And for a free piece of software, it's just solarsystemscope.com. I'll put a link down below the video to this as well, and you can come play with it yourself. It's just something really cool you can see, you can put in stops, you can go forward or backwards in time, you can keep, actual time, which is now. This is kind of what's happening right now. You can click keep same day time or whatever. It's just kind of cool that you can come out and see the solar system from different angles and watch as the planets revolve around the sun from either below or above the ecliptic, zooming out, zooming in. It's just kind of pretty cool. The one thing that, and look, we even got Ceres on here, which has that dwarf planet status now, same as Pluto. And if you're a little bit old like me, you'll remember that Ceres was not always recognized as a dwarf planet. It was basically considered just a rock out there. And so Ceres has this protoplanet or dwarf planet status now that gives it the same status as, say, Pluto. Back when I was in school, Ceres was not recognized as a planet. It was just a large object in the asteroid belt, which is on the outside of Mars, between, like, say, Mars and Saturn. There would be the asteroid belt, which a lot of people theorize that Ceres was a planet, was hit by a comet or a large object, and the remnants from the planet Ceres were scattered into what we now know as the asteroid belt that sits outside of Mars, or outside the orbit of Mars. So it's kind of interesting that Ceres is now recognized as a protoplanet, or as a subplanet, or maybe even a moon that was pulled off course. Ceres could have been a moon of, say, Saturn, or maybe even Jupiter, or possibly even Mars, that was pulled off course by something passing through with a large electromagnetic pull. Of course, here on this channel, we might say that Planet X or Nibiru passed by and pulled Ceres out of its orbit and left it in its current orbit. Or Planet X passed by one of its planets or moons, or some of the large space debris that it carries with it, smashed into Ceres, which smashed it into the asteroid belt and left a core, small piece that was small enough to classify as a protoplanet or a moon or a subplanet, leaving it out there in its own orbit now. So, however Ceres came to be, and the asteroid belt came to be, it's just interesting that now it is recognized as a type of planet, which is pretty cool. And if you go to SolarSystemScope.com, you can come here and play with this software and watch the orbits of Ceres and all of the planets in our solar system. The one thing that I don't like about this particular piece of software is, and this model in general, is that it gives people the idea that the sun is static and it's just floating in the center of our solar system, and that all the planets just kind of revolve around it. While it is true that the planets revolve around it, the sun is not static at all. It's pulling us, it's leading us through space, and we are all in tow, and we're all swirling around behind it in our own orbits, kind of like when you flush your toilet or when you drain your tub. That helical swirl that happens is how our solar system actually moves through space. And this, while it is a good way to show kind of where the planets are in relation to each other and how they move in relation to each other, and distances of each and whatnot, it's misleading because it shows the sun as a static entity when it's not. Our sun is moving through space. Here we go. It's moving through space just like we are, and its electromagnetic resonance is pulling all of us, all of our planets, all of the moons of our planets, and everything through space with it. And this is a great, here we go, a great graphical representation of how things really work. The sun is shooting along, and you can see there's a big shock wave out here that the sun is creating with its electromagnetic field of energy, and all of the planets are swirling around behind it in a helical type pattern, just like if you were, again, flushing your toilet or draining your tub. So that's been Planet Nibiru for today, and have a great day.